Alright, so picking up where we left off in the last video, just doing this last example. So we're trying to find the coordinates of the stationary points. Okay, we know that stationary points when the gradient is 0, which means we're going to have to differentiate this function here. Alright, so let's do that. So we're working out dy dx, and we get 3x squared, take 6x, minus 24. Okay, and we want to find out what are the x coordinates when that equals 0. So let that equal 0. 3x squared minus 6x minus 24, and if you work that out, you end up with x is minus 2 or 4. Okay, so that's the x value, but we need the coordinates, so you need to plug those back up into here. So remembering that we're always working on this function, so you want to put those back in there, and what you end up with is the first coordinate when x is minus 2, y is 64, and when x is 4, y is minus 44. Okay, so that gives you the two coordinates there. So determine the coordinates of the stationary points. So you get 1 mark for each of those. Now the next question says complete the graph. Okay, so what we're going to do is use these points, and I'll let you go back a screen and we'll draw on the little bit of the graph that we were given. So use these to put those in. So minus 264, we'll do that one first. So minus 264 sort of up here. Okay, and the other one was 4 and minus 44. So we had 4 and minus 44 is kind of down there. Now, it's asked us to use calculus point techniques to find those. It hasn't said anything about the x-intercepts, but because you've been given a grid, you do want to get these reasonably accurate. This is the calc section of an exam. It hasn't asked you specifically to find the roots. You can use your class pad. Okay, this is only worth 3 marks. Alright, so what I would do is jump in here, type in our function. So we've got x cubed, take 3 x squared, take 24x plus 36. Okay, now pop this in here. It doesn't really matter where those are because we know where those turning points are. All we want to do is pretty much find out where the x-intercepts are, so find the roots. Now they're nothing nice, but it's between 4 and 5, or minus 4 and 5, and between 1 and 2, and then over there it's 6, so that one's exact. Alright, so let's come back here. So we want 6. Well, we've already got the one there between 1 and 2, and we said it was between 4 and 5, sort of around here. Okay, so now we've given those points, we can draw that. Oops, trying to make it as nice, smooth curve as possible. Okay, and there we go. So that's our function there. Just filling that in. Oops. Okay, so that's our cubic. So 3 marks for that. Now the last thing says show that the equation of the tangent when x equals 3 is y equals minus 15x plus 9. So what that's saying is when x is 3, too far, x is 3, okay, we want to know what is the tangent at that point. So we're down here, sort of looking like something like that, roughly. Okay, and we're trying to show that the equation of that line is as given. Okay, so we need to find out the gradient, firstly. Alright, so we know dy dx, again, was 3x squared minus 3x minus 24. Okay, when x equals 3, okay, we can put those 3 in there, so we have 3 times 3 squared, take 3 times 3, take 24. And that's where you get your minus 15, which is good. That's what we're expecting, so far so good. Okay, we also need to know what is the y value of this function here when x equals 3. So if we pop that, and we can do this off here, we can say let's copy this down. Okay, let's define it. Of course there's numerous ways you can do this. You can do it in your head. If you think it's quicker, you can do it off the graph. Okay, or you can just go like this. 3 is minus 36. Okay, so y is minus 36. So if we went back to this point here, yep, well, we've come a little bit far down, but that's okay. So that's what we'd expect in there, minus 36 there. Okay, so what we're going to use is this gradient. Now we're saying y equals mx plus c. Okay, so we're working out the equation of that straight red line. We know the gradient is negative 15. We know the x value is 3. We know the y value is minus 36, and we're trying to work out the c value. Okay, you rearrange that, you end up with 9. Therefore, y equals minus 15, x plus 9, as shown. Okay, and of course you can confirm that on your class pad again by going f of x and do our tan line. Oops. So interactive calculation line, tan line, and x equals 3. Yep, minus 15x plus 9. Okay, so we've proved it as given. We've shown it on the class pad as well, just to satisfy ourselves, and therefore you've pretty much covered all bases.